Hey, what's up everyone? Today I'm going to go through Code Review Lab and take a look at a challenge written in Go or Golang. This is a language I have some familiarity with, but not a ton, so I wouldn't consider myself an expert at it or someone that has a ton of knowledge around Go, but that's one of the reasons I like Code Review Lab and these playground services where I'm given a variety of tools, methodologies, and a place to go learn, experiment, and get a better grasp for the things that are out in the wild. So, yeah, like I said, I'm not a big uh, user of Go, but I love the mascot so much that I actually have the Gopher Wizard. I don't know if you've ever seen this guy before, but I wanted to share that with you. So, today we're going to take a look at this challenge called Single Sign-On Auth Service. The description is review the authentication service for auth access and enterprise identity provider handling single sign-on for critical internal applications, including HR systems, financial dashboards, and admin panels. The Go-based service was recently updated to support legacy clients during a phased migration. Examine the JWT token validation logic to ensure authentication is properly enforced across all integrated services. So let's go ahead and take a look at this code base and see if we can find some sort of JWT vulnerability. Okay, so the first file I'm going to go take a look at is main.go. And what I see going on is we have a package named main. We're importing these libraries or these modules, and then we have the entry point for the Go application, the main function. And in here, I see it's using http.handleFunction or handlefunc, and what appears to be creating our API endpoints to access our API. And then we're printing out auth access SSO service starting on port 8080. And then down here, we are declaring and assigning a variable to error. And this is the shorthand. I know this isn't Go. I feel like this is called the gopher operator. I don't know if that's the actual technical term or if that's just for a joke, but I've heard it called the Go operator before because it does resemble that of a gopher with the eyes and the teeth. And it's assigning that this value here to error, and then we're immediately checking that error. If it's not nil, we're going to log a fatal error. So in Go, and this trips me up. This is why I'm not an expert at this language, but in this, because things like this trip me up, but we are declaring and assigning a variable error while inside of a conditional. So here's actually the condition. So we create and assign the value here. Then we check error right like immediately after, and it's all done with one line. It's a little different than what I'm used to. A lot of people seem to like this approach though, but this is what I see inside of main.go, so nothing too crazy. Let's move on to actually config.go and let's take a look at this. All right, so taking a look at config.go, we have a package config, we're importing OS and time. We have some, I believe, so we have global variables right here. JWT secret, which gets the environmental variable JWT secret. If that's not set, we fall back to this string, which in my opinion should be kind of a weakness. If this is the fallback, it's not a very good JWT secret. In my opinion, it is long, that's for sure, but I would argue using dictionary words for things like secrets should be a no-go, in my opinion, no pun intended. We're setting the expiration time, how often it refreshes, and then there's a database URL in here to go and talk to a database. And then get env, so key the fallback string, so this should be the fallback. Return the type string. If value is set, and this always messes with me, so value is set to OS get and env key. If that value is not empty, return value, return fallback. So pretty straightforward on this one. I think this is a weakness in my opinion, but not the vulnerable line of code. So I want to jump to users.go now and take a brief moment at this file. Okay, taking a look at user.go, we are importing errors and bcrypt. We declared two structs, so we have a user struct and credential struct. And we have ID, email, password, role, and these are type string. And then we have a email, string, JSON email, password, string, JSON password. And then we have two functions, authenticate user, get user from DB. Authenticate user passes in the email address and password. And then here, we're actually going to use the function here, which just looks like it returns nil. So that logic doesn't look like a lot's going on in here. So we have to kind of figure this out as we go. But this is saying if user is equal to nil, return nil, errors user not found. And then the line on 26 says if error, and then bcrypt compare hash and password. So we're checking the user's password. And if we have a valid user, but the password is wrong, we're going to say invalid password. So I would say this is another vulnerability, a weakness in this API. An attacker could use this user enumeration to figure out who is part of this API and effectively perform maybe brute force or password spraying attacks against this API, because this is divulging who is a valid user or not based off of these two lines right here. So this would be defining if the user was not found, return that, or return invalid password. So potential vulnerability right here as well. Let's continue on. I'm going to take a look at the handlers directory, and I'm going to start with validate.go now. Okay, so looking at validate.go, importing more libraries in here. We have a few functions. So, oh wait, we just have the one function. Okay, so validate handler, and what it's passing through, this is checking the header authorization. So it's going to check the HTTP header for authorization. If it's empty, we're going to say we're missing the authorization header and return a token string, trim prefix, auth header bearer. So a bearer token, it looks like, and we're validating that token. If there's an issue with it, we say there's a valid token or an invalid token. And then the W header set content type JSON. So our API is going to return JSON. JSON new encode map string interface, and return that as JSON. So pretty straightforward on this one as well. Let's pop over to login.go and knock out this logic. So we're importing these modules again. We have a login handler. Let's see, JSON new decode, our body decode the credentials that get passed through it. If there's something wrong with the request, we're going to say it's an invalid request. So we did something, we sent some sort of mutated request that the application couldn't handle, and we got an invalid request. User error, authenticate user, was that here? That's validate handler. Okay, so this is new. So models, authenticate user, passing creds.email, creds.password. If the error is not equal to nil, we have invalid credentials and it's unauthorized. So we let the user know, like, hey, you're unauthorized. But if we're good, then we'll generate a token for the user. But if there's an issue with this, so if error not equal to nil, then we return token generation failed, internal server error. So we made the application return a 500, it looks like, based off an issue with generating the token. And if everything is going well, then we set the content type application JSON, JSON new encoder, map string token, and then provide the token. So then the user would have the token. So handlers, looks like it's just basically checking to make sure everything's good with the token. and with the credentials and getting the user set to move forward. And wait, authenticate user was passed. Okay, that's where I saw it before. Right, models.authenticate user. Models user authenticate. Okay, that makes sense now. I'm with it. So far, I see two things, like I said, that I would consider an issue. We're going to continue reading through the auth token.go and generate.go, but user enumeration and then the backup signature looks like it's something that could potentially be brute force. So now let's take a crack at token.go. So token.go. So auth package, here's what we're importing in. So here's actually JWT version 4, a struct, user ID, email, role, registered claims. Okay, so then we have a function validate token. This is a return a string. Oh, so that's the type token string. So claim here token air parse with claims token string claims func JWT. This is a lot to handle, but okay. With parse claims, token string claims, the function, so everything incorporating the actual interface of that JWT. If token method, JWT signature, signing method is none, return nil, nil. But if everything is good, return config, JWT secret nil. I'm curious about this one, and I'm going to check that, and I want to check the JWT library in a moment. If error not equal to nil, return nil error. If not token valid, we have an invalid token, return claims nil. I need to look this up. Give me 1 second. I'm curious about this particular component here. All right, so I went over to the Go documentation and looked up the signing method none, and it's doing exactly what I thought it was doing. So the signing method none implements the none signing method, and I love this. This is required by the spec, but you should probably never use it. So what's going on here is we can set the algorithm to none in the JWT, and then tamper with it and do whatever we want to it. So I have Portswigger Academy pulled up here to define what's going on. As the JWT header can be tampered with client side, a malicious user could change the algorithm header to none, then remove the signature and check whether the server still accepts the token. So in our case, if that's the vulnerability, we can change the algorithm to none, tamper with the token, remove the signature, and if the server still accepts it, we can potentially privask, impersonate another user, so on and so forth. So looks like my hunch is correct on that one. I would say that's probably the vulnerable line of code, and that would be the third thing that I found that would be, this is the significant vulnerability, but the other two being user enumeration and the potential to brute force that JWT secret if a environmental variable is in place that doesn't have a much stronger one. Like I said, that one has decent length, but I hate the concept of using dictionary words or hard coding that value inside of the application to begin with, even if it's just the backup for it. But I'm saying this is 99%. I'm 99% positive this is going to be our vulnerable line of code. We're going to check out generate.go and wrap this up. What I'm seeing is like the big thing in here to really drive point that finding home in the token.go for this is being assigned a role, an email. We can set that algorithm to none, remove the signature, but escalate to potentially an administrative user, maybe impersonate somebody else's account, change their email, and the logic should allow us to become admin or become that user and then hijack user accounts. So I'm pretty much set on this being the vulnerable line of code. And if this is indeed it, I have a little bit of extra treat for after we're done with this lab. So, all right, so I think we're good to go. I'm going to go ahead and submit this. Let's see if I'm right. Hopefully I am. Submit solution. Thinking. Challenge completed. Okay. I was a little scared there for a second. So this authentication service contains a critical vulnerability where it explicitly allows the none signing algorithm for JWT tokens. So JWT.signing method none. Algorithms, the algorithm means the token has no cryptographic signature at all, and anyone can validate or can create a valid token without needing to know the secret key. So good stuff. It detects algorithm none. I think there's a lot of good information in here. I'm scrolling through just to get to this last bit. So it can be catastrophic and single sign-on because, yeah, we can impersonate another user. We're granted, there's privask. There's a ton that can happen. And JWTs are something that you shouldn't take lightly. It's definitely something that needs a lot of good security implementation in place. I have a quick thing I want to wrap up with though, since we solved this lab. Let's actually jump into a quick Portser Academy lab and put this to this action into practice. So let's do a quick Portser lab and see like just exactly what that algorithm none looks like. All right, so I have a little bit of a bonus. I have the Portser lab JWT authentication bypass via flawed signature verification, and we're going to put into practice that none signing algorithm. I have in Burp Suite Community Edition a extension installed called JWT Editor. There's a tab for it over here, but what we want to highlight is inside of proxy, I'm already signed in, so I logged in using the Wiener Peter credentials they give you. And if I refresh this, you'll see the traffic coming over here. And I want to take a look at the green highlighted ones. They say JWT authentication, or there's a notes in here for JWTs right there. So we know that one's embedded in here and it's inside of this cookie. I'm going to go ahead and grab this. I'm going to send this to Repeater. So this is my account, ID equals Wiener. And then I'm going to hit send, and we have a 200. What we see is we have the raw hex, but because of that extension, we now have this JSON Web Token. Follow along with me on this one. If we go to attack, and you see this none signing algorithm. So note up here, we have the signature, and we have the sub, the expiration, and the ISS. But the signature right here, the algorithm here that's set to RS256, and our signatures right here. If we go to attack and we hit none, and I'm just going to select the default value none. So pay attention to right here and what happens to the signature. We hit OK. The signature is gone and the algorithm is now none. If I hit send, everything still looks like it's just fine. I didn't get a redirection. I didn't get an error. And what I'm curious about, I'm going to render this so I can see this happening. So I see that my username is Wiener. Very funny. I'm going to go ahead and change this to administrator and hit send. We get a redirection. So let's see if we follow redirection. Okay. I see I'm taken to the login page, but I see a login panel. So what I want to now go ahead and do is take that, let's see, admin delete Carlos. So what if I'm actually given that path? Like, I want to see if that's the actual path in here. So my account ID, so there's an admin. So hold on. What if I just do admin first? Before I get too ahead of myself, I saw these labels all the time, and I feel like I know so many of them like the back of my hand. Okay, so yeah, I want to delete the user Carlos. Copy this. Go back here. So admin delete username Carlos. If I hit send, there's a redirection. It sends to admin, but it did solve the lab. So now if I go back and follow redirection, I'm on /admin, and it looks like user deleted successfully. So we see that from this response, and Carlos looks like he's gone. So I solve these labs all the time, and I remember this one off the top of my head after reading through that code, and I thought this would add a little bit more value, so I hope this helped. I hope this kind of gave a demonstration of what that none algorithm does and how it can infect and weaken the JWT and how it can cause significant security risk if that signing method none from that Go code is implemented in a production-based application. So, hey, let me know though if you want to see more Portsmouth Academy stuff on like JWTs. If you want to see more Code Review Lab stuff, feel free to comment that below. If you have any questions on anything I covered today or anything in general at all, please reach out to me and I will do my best to get back to you as soon as possible. Hope you found value in the content today. Thanks for joining me. Happy hacking.